All right, the next clip that we're going over here is on activity series. Activity series is the process in which determining whether a reaction will occur or not. I have some base examples up here. First example I have is sodium chloride and lithium. Okay, as you can see, sodium chloride and lithium are sitting there. And how do you determine whether a reaction will occur? Well, you take the charges and you look and see. And obviously a positive or cation will try to replace a cation. And then we refer to our list. And we have this activity series list. And on this list we have all of our elements ranked. You should have this list. So you can see that lithium is well ahead of sodium by 3 or 4. And so when we go to our list, I see that lithium does have the ability to come in. It is a more powerful reactant, and we would end up with lithium chloride, and then the sodium would be removed. Since it's one element, we would call that single displacement, and now the sodium is by itself. Next reaction we have is lithium chloride and gold. Lithium is positive 1, gold is a positive 1 as well. But when I refer to the list, I see lithium's up here. But gold is really low, very inactive. We all know that because gold lasts forever. Well, does gold have the ability to react more strongly than lithium at the top? And the answer to that would be no. And so we get the first time you get a chance to see what that NR means, non-reactive. It does not have the reactive capabilities to remove an element. We also must realize that we can have reactive capabilities based on anions, which are negative. Bromine is a -1 and fluorine is a -1. So instead of replacing the positives, fluorine will look on the activity series list, and we can see that fluorine over here is well above bromine. So fluorine does have the ability, so we will end up with KF, and then bromine will come over here. Now we must remember that when we go to balance this equation, both those are 2 because they're Honkelbrist diatomics. Final one I have up here is a double. It's a double displacement. So there is a positive and a negative and a positive and a negative. The best way to remember this is that the 2 highest will always be together and the 2 lowest will always be together. Okay? 2 good-looking elements go find each other because they want to, because they're the most attractive to each other. So I look, and on my list I have potassium and sodium, and I have fluorine and I believe iodine. Well, potassium is the highest and fluorine is the highest. Therefore, those 2 will choose to combine because they are the highest on the activity series, forming a new compound. So we will have a reaction, and the other elements, because they are still oppositely charged and still have some attractive nature, will form a second compound, and that would be sodium iodide.